Hello dear students, welcome to ECE Academy Benefactor. The topic of the class is a demultiplexer. The topic is from the unit Combinational Logic Circuit. Subject name is Digital Electronics. In this class we will be seeing how to draw the logic diagram of 1:4 demultiplexer. Before doing it, let us define what is a multiplexer. Multiplexer is a circuit, a combinational logic circuit that receives information on a single line. And transmits this information on one of the 2 to the power n possible output lines. Receives information on one single line and transmits this information on one of the 2 to the power n possible output lines. The selection of the specific output line is controlled by the values of the n selection lines. Okay, so we can see here, suppose if you are drawing 1:4 demultiplexer. 1:4 demultiplexer means 1 input, 4 output. 1 input, 4 output. 4 is 2 to the power 2. So 2 selection lines. So how can we draw for 1:2 to the power n demux? 1:2 to the power n demux. Demux is a short form of demultiplexer. It means it is receiving the information on one single line, D input. It is having 2 to the power of n output lines. 2 to the power n output lines. So this input is going to be transmitted on any one of received at this any one of the output lines depending on the selection lines. So here n selection lines will be there. N selection lines. So what's the definition of a demultiplexer? Demultiplexer is a circuit which receives information on a single line and transmit this information on one of the 2 to the power n possible output lines. The selection of one output line depends on or controlled by the value of the selection lines. Okay, so it is having 1 input, 2 to the power n output lines and n selection lines. So we can have 1:4 demultiplexer, 1:8 demultiplexer. For a 1:8 demultiplexer, input is 1 and 8 output lines ranging from y0 to y7, y0, y1, y2, y3, y4, y5, y6, y7. 8 means 2 to the power 3. So 3 selection lines, S0, S1, S2. Okay, so 3 select lines for 1:8 demultiplexer. In short, it is known as the demux. So let us now draw 1:4 demultiplexer. Before drawing, we should know what is the function table of 1:4 demultiplexer. For 1:4 demultiplexer, we need 2 selection lines. 4 is 2 to the power 2. 2 to the power 2. So 2 selection lines. Let that selection lines are designated by S1 and S0. And data input is 1. So input data is 1, D in. So we need to write the truth table for these 3 inputs. Selection line S1, S0 and the data input D in. So for these 3 input we will have total 8 combinations. They are 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1. For these 3 inputs we have written total 8 combinations. To enable the demultiplexer we need one enable input. When the enable input is 1, the demultiplexer is going to work. Okay, so if the enable input is 0, whatever is present in the selection lines or at the data input line, the output will be held to 0. Okay, so the enable input is 0. Don't care it is shown, because whatever the values are present here at the selection lines and data input, the output is going to be 0. So when the demultiplexer is going to give the output when the enable is 1. So we have for all these 8 possible combinations, that is from 000 to 111, we kept the enable input as 1. Okay, now see this condition. If there is no data, what will be the output? For no data, data input is 0, so output will also be 0. So for when the data input is 0, output is going to be 0. Data input is 0, so output is going to be 0. When the selection lines are 0, 0, output, this data will be transmitted to Y0. Okay, so what happened when the selection line is 0, 0, Y0 will be 1 and all other outputs will be 0. When the data input is 1, enable is also 1 and the select lines are 0, 0, so Y0 will become 1. Now here the selection lines become 0, 1, but the data is 0, so the output will be zeros. Now the selection line is 0, 1, 0, 1 means 1, 0, 1, the data input is 1, so Y1 will become 1 and all other will be held to 0. Now the select lines are 1, 0 and the data is 0. When the data is 0, the output is going to be 0. The selection lines are 1, 0. The data input is present. 1, 0 means Y2 will be high and all other will be 0. Selection lines are 1, 1 and the data input is 0. So the output will be all zeros. Selection lines are 1, 1. The data input is 1. So Y3 will be 1 and remaining 3 outputs will be 0. Okay, so depending on the selection line values, the data input is transmitted to one of the possible output line. So for 0 we can summarize it like this. When the selection lines are S1, S0, when the selection lines are 0, 0, what will be the output? Y0, Y1, Y2, Y3. When the selection lines are 0, 0, Y0 is 1 and all are 0. When the selection lines are 0, 1, so Y1 will be 1 and the remaining will be 0. 1, 0, selection line is 1, 0, so it will Y2 will be 1 and the remaining will be 0. For 1, 1, the remaining 3 will be 0, Y3 will be 1. So under all this condition, data input is 1 and the enable is also 1. This is the function table of the demultiplexer. Now let us see the logic diagram. We are having the selection lines S1 and S0. This will give S1 bar and it will give S0 bar. So we are having 4 outputs: Y0, Y1, Y2, Y3. Okay, so we want to get Y0 high and remaining 3 to be 0. Only Y0 is to be high, so we need to connect. So let us understand the data input is given to all the AND gates. Data input is given to all the 4 AND gates and enable is also given to all the 4 AND gates through the green line. So data and enable is all the time there. Data input is 1 and enable is also 1. Now Y0 will be becoming 1 when the selection lines are 0 0, that is S1 bar and S0 bar. And now y1 will be high when the selection lines are 0 1, S1 bar and S0. So y1 will be high and all y0, y2, y3 will be 0. Now to make y2 1, y2 1 means 1 0, S1, S0 bar, this is 1, this is 0. When the select lines are 1 0, y2 will become 1, y0, y1, y3 will become 0. To get y3 1, the selection lines are 1 1, S1 1, S0 1. So when the selection lines are 1 1, y3 will become 1 and these three will become 0. So this is how we can draw the demultiplexer diagram. It is known as the logic diagram of 1:4 demux. So take 4 AND gates, data input given to all the 4 AND gates, enable given to all the 4 AND gates, and connect the selection lines to get the output y0, y1, y2, y3. So in this way we can easily draw the logic diagram of 1:4 demux. If you have any queries, you can post in the comment section. This is S1, this is S0. Thank you. Good luck, students.